All right, number 5, write an equation of the quadratic function containing points -4, 0, 2, 0, and -1, -18. Write it in factored form first, then convert it into standard form and vertex form. All right, so I'm going to write this in factored form first. I need the zeros, which I have, got 2 of them. So I don't know what the coefficient is, if there's a GCF or not. But if I have a 0 at -4, then one of my factors would be x plus 4. And if the other 0 is at +2, the other factor would be x minus 2. So I write those out. And then to help me find this a value right here, what I need to do is I need to use another point. And they gave me this other point right here, -1, -18. So I'm going to plug that in and see what I get. So if I plug in -1 and -18, that means I'm plugging in an x number and a y number. So y is -18 equals some number times -1 plus 4 times -1 minus 2. Let's simplify that a little more. -1 plus 4 is 3. -1 take away 2 is -3. So now on the right side, a times 3 times -3, that makes -9a. So to solve for a, we just divide both sides by -9. That's going to tell me that a must be -18 divided by -9. Negative divided by negative is positive, and then 18 divided by 9 is 2. So my factored form will be y equals 2 times x plus 4 times x minus 2. Okay. Put this in standard form. So let me make sure I make a little note here. So that's my factored form. Put it in standard form. I would need to multiply this out. So I'm going to start by multiplying my x plus 4 times x minus 2, but then I have a GCF, so that means I just need to go back and multiply everything inside by 2 once I'm done. So x times x is x squared, x times -2 is -2x, 4 times x is 4x, and 4 times -2 is -8. Simplifying that a little bit more, I'm going to get 2 times x squared, the 4x and minus 2x, those like terms combined to just be positive 2x, and I had -8. And then because of that GCF of 2 in the front, now I'll just distribute that, multiply it times each term. So 2x squared plus 4x minus 16, that becomes the standard form. So I have factored form, I have standard form. Now one last form, I need vertex form. So remember with the vertex form, what we're wanting to do is get the x squareds and x's on one side, any other numbers on the other side, and then use an incomplete square and complete the square. So I'm going to take this standard form now. I'm going to write it out, 2x squared plus 4x minus 16. Notice it's just an expression. I don't have an equal sign here, so I'm going to put it equal to y. Because again, all expressions just equal some number. Then I'll add 16 to both sides, making 2x squared plus 4x equals something plus 16. Completing the square needs just x squared in front, not 2x squared. So I'm going to factor that out. 2 times, let's see what we would have once we factor it out. So divide both parts by 2 and you get just x squared and 2x. All that equals y plus 16. Now we draw our incomplete square. So I'm going to have x squared. The 2x splits into 1x and 1x. Remember, I have a GCF of 2, so there are 2 of those incomplete squares. Then on the other side, we just have y plus 16. The GCF on the left never shows up on the right side until we do this completing the square step that we're about to do. And this is where we complete our squares. So the outside must be x times x, and then 1s as well, which makes this bottom right corner 1 times 1, or just 1. And then when we go to complete the square on the right, this is where the GCF comes in, because I didn't just have 1 of those, I had 2 of them. So 2 times that 1 in the corner makes 2 that needs to be added over here. So when I write my expression, now I have 2x plus 1 squares equal to y plus a total of 18. And then finally, I will take away 18 from both sides so that this gets back equal to just y, like the original problem did. And then we get 2 times x plus 1 squared minus 18. That's the vertex form. And if I wanted to know what the vertex was, remember it would be the value we could plug into this parentheses right here that would make it a 0. So that would be -1 for the x. And then if we plug that -1 in, then this whole term right here just becomes equal to 0, and it would just kind of cancel out, leaving -18 for the y. Okay. Get rid of all that scribble there. So -1, -18 will be our vertex. And hey, that was the point they gave us originally. So they gave us the zeros and the vertex. But we weren't told specifically that was a vertex. There is a little bit of simple math we could have done to figure that out earlier, but even if we didn't, we still get the right vertex form. Okay, now number 6. The graph of f of x equals 2x squared minus 3x plus 5 will be translated 8 units down, producing the graph of q of x, which equation would represent the new function. Well, anytime we translate a graph down, remember that has to do with that k number added on the end. Okay, so we have f of x, and now we want to turn it into q of x, and it says that the way you do that is you translate it 8 units down. So we need to take that original graph and subtract 8, right? We don't want to do the -8 in the parentheses where the x is, because that would shift it left to right. We don't want to multiply by -8 or +8, because that would stretch it or shrink it. So if we just did 8 or -8, that would stretch it 8 times taller, and then either leave it up or flip it upside down. We just want to slide it down. So all we're going to affect here now is the y-intercept. So if you take that original equation, 2x squared minus 3x plus 5, and you want to move it 8 units down, you just take away 8. And if you do that, +5 and the -8 combined to just give you -3. So our correct answer here would just be A. Okay. So that's number 5 and number 6.